what I wanted to do today was just spend a little bit more time talking about sketching the cubic function, because this really is a very, very important skill that you need to be able to master. And irrespective of whether they ask you to sketch it or not, they are going to ask you to calculate the x-intercepts, the coordinates at the stationary points, and very definitely the x-coordinate at the point of inflection. So I just wanted to make sure that everybody had an opportunity to thoroughly practice that. I know it's something that I went through last time. I think I went through it quite quickly. So that's why I just thought that it was really good for us to just try this again. So I've chosen this particular cubic function over here. And I want to see if you guys can remember how to determine, first of all, the x-intercepts. So this is going to be very much more about you guys writing and working answers out instead of me doing it for you. Can anybody tell me, if they ask you to calculate the coordinates of the x-intercepts of a cubic function, what are you going to do? What's the first thing that you will need to do? Perfect. Okay, so Atlichang in the chat says take x cubed minus 2x squared minus 4x plus 8 and set it equal to 0. Perfect. Wonderful. Okay, now what's the second thing we're going to do? Now that we've made y equal to 0, what's the second thing that we're going to do, Matrix? Even if you're shy and you don't want to talk, you're welcome to pop it into the chat. What's the next thing that needs to happen here? How? Okay, so Orotile says take out the common factor. Okay, so factorize, quite right. Okay, so Orotile, if there is a common factor to be taken out, then we can do that. But yes, factorizing is the right idea. Okay, now how are we going to... Yes, we're going to have to use our factor theorem. So that's correct, factor theorem. How do we use factor theorem to determine how we're going to factorize this? Remember, we have not been given any linear factors. So what are we going to do at this point, Matrix? Cool, we have to find our factor. How are we going to do that, Cassandra? How are we going to find our factor of f of x? What do we do here? We're not going to differentiate, Kanisa. When we differentiate, then we are working to find the coordinates at the turning points. Okay, Dylan, I think you're on the right track here. And there's another you said take out a highest common factor. If we can, yes, then that would be great. Amanda, you're saying sub n -2. Yes. Look at what Cassandra's saying, everybody. So sub n plus minus 1, 2, 3, whatever it is, gives us 0, then it's our factor. That's quite right. Okay, so Kia Malloy says f of 2. So Kia Malloy, are you saying that in this case here that f of -2 equals 0? Is that correct? Cool beans. Okay, so if that is indeed the case, which I'm sure it is, then that means that x plus 2 is a factor of f of x. Okay, so we can now write x plus 2 over here, and that means that we now need to work out what the values of a and b and c are. So when I say a, b, and c, I mean this. So ax squared plus bx plus c. How am I going to work out what A is? Matrix, this A over here, how am I going to calculate A? Sure, you can use long division, Dialer, no problem. A little bit more difficult to use long division, but you can use long division and you can divide your trinomial. So instead of factorizing it here, you'd still have to find your linear factor though. How are we going to work out the value of A? Okay, so if we're doing it by the inspection method that we were talking about last time, we are looking at the first term in the first bracket and the first term in the second bracket. Okay, so in other words, let me just get rid of this dark blue over the A. We are multiplying these two here together. All right, so in other words, this term here with that term there in order to get this term up here. So we see that when we multiply x with ax squared, we get ax cubed, and it is equal to 1x cubed. This is what's been given to us. So dropping our coefficients, in other words, the x squared, we can say, sorry, it's dropping our variables, the x squared, we can then match our coefficients and say, well, in this case, a has to be equal to 1. Okay. Then we can work out the value of c in the same way, because this term over here multiplied by that term over there gives us this term here. So in this case, we will say that 2 times c will be equal to a. Divide both sides by 2, and c is 4. We're nearly there. This is the difficult one, okay? We've got to work out the value of b. So now this comes from more than one place, all right? So when we work out b, we have to multiply this term with this one, okay? So x with bx, and we also have to multiply 2 with ax cubed. Don't know how dark that blue is. It doesn't look very dark to me at all. All right, so now when we multiply x with bx, we get bx squared. When we multiply 2 with ax squared, remember a is equal to 1 in this case, that gives us 2x squared. And then what is it equal to? It's equal to this, okay, or this over here, minus 2x squared. All right, so working with our coefficients now, b plus 2 equals -2. So we're going to take this 2 over to the other side, and b will be equal to -4. All right, everybody happy with that? Okay, so now I can go and fill these values in. All right, so I've got x plus 2 times, that was 1, b is -4, and c is equal to 4 in this case. No problem. Oko, do you mean the step in the blue?
Yes, ma'am.
Okay, I know that is the difficult one, and I know this light blue marker that I used is a bit difficult to see. I'm just going to write on the side over here again, Oko. All right, we have got x plus 2, and then we've got ax squared plus bx plus c like this. So what I was trying to show you, Oko, was the two terms that are going to be multiplied together, all right, to give us that b term is going to be this one here and that one there. That's where the bx squared comes from. Okay, so x times bx is bx squared. And then the other one that we have to multiply together, right, is this 2 over here with the ax squared. So it's the first term in the first bracket with the second term in the second bracket, and the second term in the first bracket with the first term in the second bracket. We need to know what the value of A is before we can work out the value of B. So in this case, so it's this one here and that one there, and this one here and this one here. Okay, Oko? So A is equal to 1. So 2 times 1x squared is 1x squared. And now we're going to go back. And again, we're looking at our original equation. So whether I look here or whether I look up here, it's the same thing. All right, it's going to be equal to minus 2x squared. And then I'm going to drop my variables and work with my exponents. Listen to me, work with my coefficients. So in this case, B is going to be equal to -4. Okay, does that make sense to everybody? I know that is the difficult one. No problem, okay. I'm glad you asked. Okay, I'm sure there were other people that were also struggling to understand that. Okay, so now our last step. Okay, so point number 3 here. So number 1 was making y equal to 0. Number 2 was finding our linear factor by subbing in plus or minus 1, 2, 3, etc. Okay, the third step was determining the coefficients in our trinomial, or maybe I should rather call it a quadratic factor, because it's not always a trinomial. It could be difference of squares. Okay, so that's the third thing that we need to do. The fourth thing that we're going to do, okay, is factorize our quadratic factor. Okay, so in other words, I'm going to highlight it quickly for you. I'm sure you know which one I am referring to, but this over here, this now needs to be fully factorized. Okay, and as it turns out, that is a perfect square trinomial. So it's going to factorize into, well, that's our first factor that's coming down, and then our trinomial is going to factorize into x minus 2 times x minus 2 equals 0. Okay, so because this bracket is repeating itself at the end here, it means there are going to be how many x-intercepts, Matric? How many x-intercepts in this case? Lovely. Yes, well done, Kanisa and Leoborna. Yes, lovely, lovely, guys. And Oko and Aluwani. And Leroy, good, cool beans. Okay, yes, 100%. There are 2 x-intercepts in this case. Either x is equal to -2 or x is equal to 2. What can you tell me about the x-intercept x equals 2? Why is that? What is special about it? Can anybody remember from our discussion last week? What's special about x equals 2 in this case? Aha, there we go. Wow, guys, that's amazing. I'm so pleased. Yes, perfect. It is also a turning point. Good. All right, so when we see the bracket doubling up like that, our x-intercept is not just an x-intercept, it is also a turning point. Okay, and then we will expect that answer when we are calculating the coordinates at the turning points. All right, very, very nice, Matrix. That really is fantastic. Good work. Okay, let's go on and let's write down the coordinates of the y-intercept, which is the next thing that we need to do. So we've done part number 1, which is working out the x-intercepts. Second bit now is the coordinates at the y-intercept. So again, if we go back and we have a look at our equation, right, maybe what I'll do is just copy it and paste it over here for us as well, so it's there. What can we say about the coordinates at the y-intercept? Can anybody tell me that from looking at the equation?
It's 0 and 8, ma'am.
It certainly is, Cassandra. Okay, yes, Dylan. Okay, y is equal to 8. Lovely. All right, so if there is a number on its own, a constant term, in other words, we sometimes call this letter D, that number there, that is going to be, yes, Elam. I love it, guys. You're doing so well. Very nice. Okay, that is going to be our y-intercept. Okay, so if we wrote down the coordinates at the y-intercept, it would be 0 and 8. Lovely. Okay, so we've done this, we've done this. Now we're going to worry about our coordinates at the turning points. Okay, so what happens at the turning points? What's happening at the turning points? What is the graph doing at the turning points?
The graph is stationary at the turning point.
Absolutely. So the graph is changing direction, 100%. Okay, so insofar as something happening with gradient, the graph is changing. All right, so gradient is equal to, yeah, there we go, to Malone, the graph changes direction, quite right. Okay, so we would then say that at the turning point, the gradient is now lovely. Lovely, Leoborna, Atlichang, thank you. Quite right, the gradient is 0. Okay. What is the gradient? So how else? The gradient is the derivative. Or in terms of what we're working with here, the gradient is f prime x. Okay, so we are now going to use the derivative to calculate the coordinates at the turning points. All right, so we use the derivative to calculate the coordinates at the turning points. Okay, first derivative, quite right. Okay, so the first derivative is what we use to calculate the coordinates at our turning points. All right, and that is because the gradient at the turning point is equal to 0, as so many of you have already said. Yes, so we have to take the first derivative. Quite right, Elam, quite right, Atlacham. We have to take the first derivative, yes. So we are going to say f prime x. And now we're going to derive f of x. So that is going to give us, hopefully everybody's thinking the same thing, 3x squared minus 4x minus 4 in this case. All right, so we have to write that down. We have to write down the derivative. And I see Atlachang is seriously on the ball here and has put in f prime x equals 0. Yes, you must show this 0 matrix. You get a mark for it. Okay, so with the derivative, the gradient at the turning point is 0. So we must write the 0. Okay, because there's going to be a mark here for your derivative, and there's going to be mark for you writing 0. Okay, so don't forget to do that. If this first derivative is nasty and you're not sure how to factorize it, you can use the quadratic formula. Okay, so don't forget about that. You can use the quadratic formula here. If you use the quadratic formula, you must make sure that you have showed that you have subbed into it. Okay, so either you're going to show that you've subbed into the quadratic formula, or you're going to show that you factorized. Okay, so I'm going to factorize at this step over here. 3 is a prime number. All right, and now I've got to think about what's going to go at the end. All right, so I want minus 4 in the middle. How am I going to factorize this, guys? What do you think I should do here? Or should we do here? That's not going to work, is it? Okay, +2 and -2. All right, let's try that and see if that works. There is actually a way that we can do this. What we can do over here on the side is we can get 3x and x, and someone said 2 and 2. So if we come down here, that would give us 6x. Up there, that would give us 2x. We want -4x, so we want -6 + 2. So it's got to be +2 over here and x -2 over there. Quite right. Okay, so +2 -2 in this case. Good job. Well done. Yes, that's it, Ria. We're quite right. Okay, now x is equal to -2 over 3. Oh, look there. This is the answer we were expecting. X is equal to 2. Remember, we knew that. We knew that from up here. Okay, so we were expecting our answer. That means it probably is easier to use the quadratic formula. Probably is. All right, so your option here, right, but you must show that you've subbed into it. Okay, Anga, you've got to show that you've subbed into it. So x equals, in this case, -b plus or minus b squared minus 4ac all over 2a. Okay, you've got to show either this line here, I'm going to highlight it in pink. Got to show this or this. Okay, one or the other. Okay, but if you aren't good at factorizing, don't stress yourself out about it. Just use the quadratic formula. There is a lot of the time there is a mark on this line, an accuracy mark. So if you are using factors and you leave off the equals 0, they will penalize you for that. So be very careful there. Do not leave off the equals 0. Okay, and then here a mark for our answers. Okay, so we already know that when we sub in 2, we'll get 0 as an answer. So we know that 2 and 0 is a turning point and x-intercept. What do we need to do with this -2 over 3 matrix? Where's it going to go? It's going to go back into the original. Okay, so we're going to calculate f of -2 over 3. And normally when a horrible fraction like -2 over 3 goes in, we normally get a horrible fraction out as well. So don't be scared about that. Don't leave off the negative. Talk to yourself quietly inside your head while you're working. Remind yourself to copy everything carefully. And then once you get to this point over here, you let your calculator do the rest. Okay, so someone on their calculators, please work that out for us. I actually don't have my calculator. I'm just going to grab it quickly. Okay, I'm back. Cool. All right, so 49 over 8 or 9,48. Cool. Is everybody else getting these answers as well? Good. Good job, guys. Lovely. Cool, that's great. Excellent. So if you can do these steps over here, Matrix, these are a lot of marks for you. If they ask you to calculate the x-intercepts and they haven't given you a linear factor, there can be at least 5 marks on this. So if you know how to do this, that's 5 relatively straightforward, easy marks for you. And it's the same with you working with the first derivative and determining the coordinates at the turning points. There's at least another 4 marks there as well. Okay, so that's at least a solid 9, maybe 10 marks on the cubic function that you can get. All right, without too much difficulty. That's why I just wanted to practice this again with you, and I hope you found this useful. Our last step now is, of course, just to go ahead and draw the graph. Okay, so from the last time that we were together, I wonder if there's anybody who can tell me what shape this graph needs to be. So from looking at the f of x equals x cubed minus 2x squared minus 4x plus 8, how do I know what shape cubic function I'm supposed to draw? A smile. That's one way of looking at it. Okay, but I'll wear to when you say it's a U shape, okay. So a U shape is like that. Is that what you mean? Okay, but is this a cubic? Isn't this a parabola? And isn't it x squared, not x cubed? Ah, there we go, there we go, there we go. Okay, so look down here, guys. Okay, Kanisa and Oko and Alwetu, look at what Leobona and Riabilwe are saying. Okay, they're using the words concave up and concave down. Okay, so that's really, really great that you remembered those words and that you're able to use them. I am super impressed, okay, because all 3 of you are correct. Okay, you too, Tendai. Okay, it's first going to be concave down and then concave up. Okay, that's not a very good drawing, but you understand what it is that I'm getting at. Okay, so first concave down and then concave up. Quite right. So now we've got to try and figure out how we're going to get it onto our axes. Okay, so let's just go back and remind ourselves. It's concave down and then concave up. It has an x-intercept at -2 and an x-intercept at 2, which is also a turning point. Its y-intercept is at 8, and then its so the first turning point that we would encounter would be a maximum, and the coordinates at the maximum are -2/3 and 49/8. So in which quadrant is this maximum? In which quadrant is our maximum, Matrix? So this point that we've calculated over here, all right, this -2/3 and 49/8. In which quadrant is that point going to be plotted? Ah, good, Primrose. Yes, Juanita, the second quadrant. Good, 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 good. Okay, so the graph is going to do something like this, and I hope that this is what you guys are thinking as well. Okay, so it's going to come up here, it's going to reach a maximum, it's going to come down, whoopsie daisy, my shape is not brilliant this evening, and then it's going to go on and do something like that. Okay, not fabulous, but not too bad. Okay, and then I have to label the intercepts with the axes and my turning points. So this point over here is going to be the point -2/3 and 49/8. This point over here is 2 and 0. Don't forget about the y-intercept. For some reason, we often do. And then we end up losing marks. Okay, there we go. We've sketched our cubic function. Okay, so here, matrix, we are going to be marked on shape. So that's the whole concave down, then concave up. We're going to be marked on our turning points, and we're going to be marked on our intercepts with the axes. Ooh, Angus says 49/8 was wrong, was it? Okay, hang on a second. Let me go and double check. You said you've made a mistake. I'm also just going to put it, sorry, I just presumed that what you guys had given me was correct. I also didn't check. Let's just sitting in -2/3 squared. Yeah, I'm getting 256/27. Yeah. Me too. Okay. Never mind. At least we discovered this. Okay, not the end of the world. Okay. Thank you for going back and double checking. That was very responsible of you, Angus. So thank you. Okay, so it's actually 256/27. Okay, which is pretty close. It is 9,48, isn't it? Okay, so let's just go back and go and change that. So here, this is meant to be 200, whoopsie daisy, 256/27. There we go. Okay, are there any questions? Everybody happy with us? Yes, so in actual fact, the 9.48 is correct. So 256/27 is 9,48. Okay, Leroy. So whoever got 9,48 got it right in the beginning. It was just, I'm gonna just press something wrong on the calculator. Okay, does that make sense? Everybody's sorted.
Give it, please.
Okay. Hi, yeah. Thanks, Nelly Sweat. You beat me to it. Wonderful. How's everybody feeling so far? Cool. Now, something that we haven't discussed here, and I don't want to sort of keep laboring the point, and I don't want you guys to be bored or anything like that. But I'm just going to ask, and if it's all fine, then that's okay, and then we can move ahead. I just wanted to know how you would feel about one like that. Would you know what to do in this case? Where it's now a different shape. So in other words, it's -x cubed. Do you know how to factorize that to find the x-intercepts? Okay. All right, perfect. That's fine. Not a problem. Then what we can do is move on to the next thing that I had put down for us. Now, something else that we love to do to you guys, okay? And if you go and have a look at past paper questions, right, you will see that this comes up, I wouldn't say very often, but it certainly does, come up. Okay, so they could ask us to draw a function, and in this case, they've told us it is a function defined by g of x equals ax cubed plus bx squared plus cx plus d. Yes, sorry guys. If they ask you for the point of inflection, then you can calculate it. Do you want me to quickly do that and then we can come back to this? Okay, so if we just very, very quickly do the point of inflection here, you only if they ask you to calculate it. If they don't ask you to calculate it, then don't worry about it. Okay, so now point of inflection, let me just make some notes here for you guys in case you want to come back and come and watch this. Okay, so point of inflection. Okay, so the point of inflection is where concavity equals 0. Okay, so in other words, your second derivative is 0. All right, so in other words, for this particular graph, it is concave down, okay, and it's concave down, and it's concave down, and it's concave down up to a certain point, and then it stops being concave down, all right, and it starts being concave up. Okay, and the point at which it changes concavity is your point of inflection. Okay, so that's where it changes from being either concave down to concave up or concave up to concave down. There are two ways that you can calculate the coordinate or the x coordinate at the point of inflection. Okay, and the first way that you can do it is, as I've mentioned over here, which is to use the second derivative. So you are going to derive the first derivative. So if we know that the first, now remember that this is our first derivative up here. Let me just highlight it in yellow for you. So if you've got that on your page, just work from there. Okay, you don't have to go and rederive all the way from the very beginning again. So your first derivative is 3x squared minus 4x minus 4. So I'm just going to write that over here. Our first derivative was 3x squared minus 4x minus 4. So now when we work out our second derivative, we're going to say 2 times 3 gives us 6x minus 4. So at the point of inflection, concavity is 0. So that's why we make f double prime x equal to 0. Okay, and it's equal to 6x minus 4. I'm going to take my 6x over to the other side, and I'm going to divide both sides by negative 6. And that means that x is going to be equal to negative 2 over 3. Oh, sorry, positive 2 over 3. Sorry, positive. Because a negative divided by a negative is a positive. Okay, going to be 2 over 3. Is everybody happy with that? Or my alternative at this point, okay, is to use midpoint formula. Okay, not midpoint theorem, midpoint formula. Okay, and what you can do here is your point of inflection is going to be midway in between your turning points. So we know our one turning point is at minus 2 over 3. So we're going to say x equals minus 2 over 3 plus our other x at our other turning point, which is 2. And then we've got to divide that by 2. All right, so you can do that on your calculator. Yes, of course. Sorry, guys, it's been a long day. I beg your pardon. It is 3/2, you're quite right. Quite right. And what on earth am I writing here? Oh, no, that is correct. That is correct. Yeah. No, it was 2/3. I was right in the beginning. Yeah. Sorry. Yeah, because we're dividing by 6. Yeah, so the bigger number's got to be at the bottom. It is correct. It was 2/3. Okay, all right, never mind. Okay, I hope nobody's confused now. Okay, but we've divided. So at this point over here, maybe I should put it in. Okay, let me put it in a different color and maybe that'll help us a little bit. Okay, so at this point over here, matrix, come on, pen. We are dividing both sides by -6. Okay, so -4 divided by -6 is 2/3. Or the other way that we can do this is using midpoint formula. Okay, so midway between the two turning points. Okay, so I'm adding the one x to the other x and then dividing them by 2. And you should get the same answer, 2/3. Okay, let's just double check that we do get that. And we do. Yes, that's correct. That's correct. Sinisipo, that's quite right. When you divide -6 by -4, then you get 3/2. Absolutely. But here we were dividing -4 by -6. Indeed. Okay, are there any questions? I hope we're all feeling good at this point. Can I move on then? I presume so. And I'm going to go down to this. Okay, so I just want to talk about this a little bit. This is something that's a bit more tricky, right? But irrespective of how good or bad we may be at maths, oh, good. I'm glad to hear that. It is the responsibility of our teachers to show us everything, okay? Because who am I to say what you can and cannot answer? All right, so I'm never ever going to put a ceiling on you. And in my opinion, we can do all the questions, even the most difficult ones. We just do them as examples. Okay, so that's the sort of category that something like this falls into. We've got the function g defined by g of x equals ax cubed plus bx squared plus cx plus d, and it has the following properties, right? So we've got to use this information to draw a neat sketch of the graph of g without actually solving for a, b, c, and d. Okay, so we don't want the values of a, b, c, and d. We're going to draw the graph without it. So that means we need to carefully scrutinize what it is that they have given us. So let's do it bit by bit, okay? So this first bit over here, g of 0 equals 32. What do you think that means? Wow, Dylan. There we go. All right, how did you know that, Dylan? How do you know that that is the y-intercept? What is it? No, Ominam, you don't. Careful, Dylan, not because y is 0, because x is 0. Remember, the number that goes in the bracket is the value of x. Remember, it's g of x. Exactly, right? So remember, if I write g of x equals whatever, okay, this is my X value that's going in here, all right? This entire thing is my Y. All right, so what this is telling me is that when X is 0, no problem, Dylan, don't you stress. Okay, to calculate the X-intercept, you sub in 0. Okay, so this is not the X-intercept, this is the Y-intercept. Okay, so matrix, this over here, let's draw an arrow and come down here. This is the Y-intercept. Not the X-intercept, it's the Y-intercept, because X is 0 when Y is 32. That's what it means. Okay, so it is the Y-intercept. What letter, incidentally, does that represent in my original function? Ha, well done. Yes, Leoborna and Elam have got it right. Okay, lovely. So they told me not to solve for these letters. I don't need to, but I'm just pointing it out to you. Okay, so that's correct. D is indeed equal to 32. Okay, now let's look carefully at the rest of the information. Okay, so the next point, I'm going to highlight it in a different color. The next thing that they tell us is that G of 4 equals 0. What does this mean, matrix? How clever are these matrix, Neliswa? Amazing. Yes, 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 Juanita. Quite right. Okay, G of 4 is 0. Okay, so Y is 0 when X is 4. That's what this means. I'll say it again. Okay, Y is 0 when X is 4. Okay, good job. Okay, so that is an X-intercept. All right, Y is 0 when X is 4. Lovely, 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 lovely. Yes, you've all got it. Yes, aware to Tendai, Amanda, Juanita, 100%. What does this bit mean? Exactly. Exactly. That's it. Well done. Okay, it is another X-intercept. Okay, it is another X-intercept. When X is equal to -2, Y is equal to 0. Another X-intercept. Yes, 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 yes. Okay, cool. We're breaking this down. Okay, next thing. Okay, let's go and have a look. I'm going to choose another color now. All right, let's go with lavender. What does that mean? G prime 0 equals 0. You guys are too clever. Oh, wow. Okay, very nice. Okay, so they are telling us, all right, that the gradient, so what this means for us, and again, I'll just write it in words for you. Oh, I don't have a purple pen right now. Let me find purple. Purple. Okay. So what this means is that the gradient is 0 where X is 0. Okay, so the measure of the gradient is this one. That's the measure of the gradient is 0. This is the value of X where it happens. Oh, there's lots of stuff. Oh, turning point, turning point, turning point. I know, aren't they amazing, Neliswa? Sure, you guys are fantastic.
Yeah,
awesome,
it's
awesome,
so
awesome.
amazing.
Hey, I'm
It's so amazing. Today there was 2 friends on the roll.
Wait,
I like what I
certainly
see.
Yeah, me
Keep
too.
it up.
Me too. Okay, and then this one over here, Same story, hey. All right, G prime 4 equals 0. So the gradient equals 0, where x equals 4. Okay, now again, look here, guys. When x was equal to 4, there's two things going on here. So it's an x-intercept and it's a turning point. Can you see that from the information that they've given us? Does that make sense to everybody? Okay, so based on what they've told us here, we can see that when x is equal to 4, the gradient is 0 and y is 0. That means it has to be an x-intercept and a turning point. Okay, so this gives us, we're starting to collect information. We're starting to understand how we're now actually going to draw this graph. The last thing now, what we've got up to this point is the y-intercept, the x-intercepts, and the x-coordinates at the turning points. We know nothing about the shape. We do not know if the graph is concave down and then concave up, or concave up and then concave down. Yes, Nelisa, good question. So they need to give us some more information because we don't know at this point, are we sketching the graph like this? Or are we sketching it like that? Okay, so we need some more information, all right? If the graph looks like the one on the left, okay, remember so in other words, the a from ax cubed. So if this a over here is a positive number, the graph is going to be concave down and then concave up. If that a is a, sorry, I've written my sign the wrong way around, I beg your pardon. Sorry. A is positive, and then over here where a is negative, then it's going to be concave up and then concave down. Okay, so this graph over here, where a is positive, what can we say about what is happening between the turning points? What is happening with gradient? Okay, the graph is decreasing. Okay, it's negative. Okay, over here, my turning point is there, my turning point is over there, then my graph is increasing between my turning points. Okay, does that make sense to everybody? So a graph that's concave down and then concave up is decreasing between its turning points. A graph that's concave up and then concave down is increasing between its turning points. Okay, so it's important for me to know this. Okay, in terms of the information that I've been given here, because they've told me the value of x at the turning points, haven't they? They've told me that at the 1x at the turning point is going to be 0, and the other one they told me, I'm just going to highlight it here in green, was going to be 4. Now I need that because of what they're telling me here. So here they're saying g prime x is greater than 0. If x is smaller than 0 or if x is greater than 4. And they're also saying g prime x is smaller than 0 if x is greater than 0 but smaller than 4. Okay, g prime x greater than 0, is that increasing or decreasing? G prime x greater than 0, is that increasing or decreasing? Increasing. Okay, so g prime x greater than 0 belongs here. Gradient is positive. Lovely, matrix. Okay, gradient is positive. G prime x means, let's just get rid of that, G prime x, left out the prime, smaller than 0 means gradient is negative. Okay, so it is decreasing. So let's go and have a look what's happening between the turning points. This is between, that's how we write between in maths, between 0 and 4. So between the turning points, the gradient is negative. Between the turning points, the gradient is negative. That's what this entire line means here. The gradient is negative between the turning points. So now my question to you is, am I going to draw a graph that is concave down, then concave up, or concave up and then concave down? You can put your answer in the chat. What do you think it is? Concave down, then concave up, or concave up, then concave down? What do you guys think? You're too clever. Oh, well done, Matrix. Well done. That's lovely. And Tumaleng and Sika, Riabilwe, Kanisa, yes. Yes, yes, yes. Brilliant, 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 brilliant. Concave down, then concave up. All right, so we've got just enough time to be able to finish and draw this graph. Let's grab a set of axes here, because mine are always terrible. All right, okay. So we know that it's concave down, then concave up. We know that it goes through 32 as its y-intercept. What else do we know? So there's a turning point at 0 and there's a turning point at 4. Okay. So what is this graph going to look? Oh, Tendai, absolutely. Okay, so the reason that the graph is going to be concave down and then concave up is because over here, it is decreasing between its turning points. Okay, so that's why it's concave down and then concave up. So it looks like this one over here. Okay, it's decreasing between the turning points. Okay, gradient is negative between the turning points. Okay, so this graph looks something like that. Again, it's not the most brilliantly drawn graph that I've ever created, but what we see here in this here, so can you see it's decreasing between its points? So the one turning point was at 0, remember the gradient at 0 was 0, the gradient at 4 was also 0. So we know that when x is equal to 0, that is a turning point. That also happens to be our y-intercept. Okay, because the y-intercept also has 0 as its x. Over here, our other turning point, which is our other x-intercept, was at 4 and 0. And if memory serves me correctly, -2 was another x-intercept. So that would be that point over there, which would be -2 and 0. Okay, it's decreasing between its turning points. And then here, can you see this line here tells us that the graph is increasing when x is smaller than 0. So that's this bit over here. The graph has a positive gradient when x is negative. And it has a positive gradient when x is greater than 4. Okay, so all of our information fits perfectly. And oh, Dylan, unfortunately not. You need to know what all of that information means.